this lesson, we're going to talk about domain and range, and we've kind of touched on it a little bit, but now we're going to kind of go in a little bit more depth. But first, I want to start by talking about a couple different types of notations. So as we go along and we indicate our domain and range, we are going to be using different notations. And the first notation we're going to talk about is set builder notation. We also call this set notation, and we may have talked about this a little bit, but I want to go into a little bit more depth. So a little bit about set notation. So it looks something like this. If I were to indicate my domain using set notation, I would always use my little squiggly brackets, and I would use the variable x since my domain is my x, and then a little line, which means such that, and then I'm going to indicate my variable x again. And this is a new symbol. Everything we may have done up to this point, we may have made it look like this, like x such that x is equal to a number. But this time we're going to be using something else. We're going to be using this little letter E, which means exists. And then we will be using this new symbol R, which represents all the numbers in the real number system. So we'll talk a lot about this as we go along, but the range looks pretty much the same. The only difference is my variable is y, since I'm looking at the y values. The other type of notation that we're going to be using is something called interval notation. And these are three different types of interval notations. And I kind of wanted to walk through how you use interval notation. And then we're going to do some examples on how we incorporate both set notation and interval notation. But I want to kind of show you the basics of interval notation here first. So if you look at my graph that I'm given here, basically what I want to do today is look at the difference between domain and range. And if you look here, it says that my domain values are all of my numbers between negative infinity and infinity. Here's what this means. If I'm looking at all of my x values on my x-axis, I can see that using this function that I'm given, the point right here on my function has the domain value of -3. The point that I am putting my pen on right now has a domain value of 4. And each one of those points on that line also has a domain value. And if I were to extend this graph, which is what those arrows are saying, it says that I will also have a domain value for this point right here. And it will continue on and on in both directions. And therefore, my domain is all of the numbers from negative infinity to infinity. Similar to my range, I'm going to go ahead and erase my, my blue markings here so I can show you my range. But similarly, my range works the same exact way, except now I'm going to be working with my y-axis. So if we're working with our y-axis, you can see that the point, this point right here has a corresponding y value. And this point right here is a corresponding y value. And they always will have a corresponding y value as long as this graph extends in both directions. And therefore, you will have a corresponding y value for every point from negative infinity to infinity. Okay, let me show you a different example now, because sometimes as I progress through these examples, you're able to see all of these different types of domain and ranges. On the next function, you can see that I have a line, but I have two solid dots at each end. So if I were to look at my domain, you can see that my domain is going to end at this point right here. And it's also going to end at this point right here. So my domain exists everywhere between these 2 points, meaning every single one of these points is going to have a corresponding domain value. And since those 2 points on the end are filled in, that means that it also includes those 2 points. And therefore, I'm going to represent my domain value by these little brackets, which mean include. So I'm including the point -5 and everything in between, and then I'm including the point 3 and everything in between. So that is what interval notation looks like for a graph like this. Now, let me go ahead and erase my pen, and let's take a look at my range. Okay, here's my range. Again, I'm going to be looking at my y values. So you can see that my graph is going to end at the highest value, y value of 3, and it's going to end at the lowest value of y is -2. So to indicate this, I'm going to look at my points, and I'm going to see that they are both included. And I'm going to say that -2 is my lowest that is included, and 3 is my highest that is going to be included. And that also incorporates everything else in between. All right, and then my last one's just to kind of show you the difference between those two. Let's look at the domain of this function. You can see that the only thing that I changed was that the value down here is not included. If you remember anything from inequalities, you remember that an open circle does not include the given point. So let's take a look. My domain. The lowest domain value is going to be right here at -5, and then my highest domain value is going to be here at +3. But since I have my -5 included, I'm going to use a bracket. So bracket -5, and then it goes all the way up to my 3, which is not included. And I'm going to indicate that by a parenthesis. Likewise, for the range, it works the same exact way, but this time I'm going to be working with my y-axis. So my highest y value is going to be 3, and my lowest y value is going to be -2. So since my +3 is an included value, you can see that I indicated a bracket with a 3. And since my lowest y value of -2 is not included, I incorporated a parenthesis. Okay, so that's kind of the basics of those two notations. Now let's go see how they work. All right, I'm given this first graph here. This is a graph of an ellipse. So I want to indicate my domain first. So if I look at my domain, my lowest point, let's pretend that that graph goes all the way to the end. I apologize that it looks a little funny. But my lowest domain value is going to be right here at -4. My highest domain value is going to be here at 3, meaning those are the points that are my end points of my domain. But I can also see that everywhere in between has a domain value. So I want to represent the two numbers, -4 and 3, and everywhere in between. So I'm going to first do that in set notation. I'm going to do a little curly bracket, and I'm going to say x my domain such that my lowest domain value is -4, and it's going to include all of the numbers that are greater than or equal to -4. So I'm going to incorporate an x right there, and that are also less than or equal to 3. What this is indicating right here is that x is going to represent all of the numbers between -4 and 3. If I were to represent my domain in interval notation, I would indicate it as a bracket, -4, comma, 3 with a bracket, because those two endpoints are going to be included in my domain. Now let's look at my range. My range is a little bit different here. All right, I'm going to use a green one to represent my domain. I'm sorry, my range. All right, here's my range. My highest range value is going to be 2, and my lowest range value is going to be -2. So to indicate that, I'm going to say y such that, and now I want to say between -2 and 2. So I'm going to start with my lowest number, -2, is less than or equal to y, which is less than or equal to 2. So that indicates that y is between 2 and -2. My interval notation is going to be bracket, -2, comma, 2, because it includes those 2 points. Okay, let's look at another one. This time I just have a straight line. This is called a linear function. So again, we kind of already talked about this a little bit when we were looking at the interval notation, but if I want to indicate my domain values, we can see that each point on that graph is going to have a domain value. And since it has arrows at the end, I could extend that linear function, and it will always continue to have domain values. So therefore, I'm going to say that squiggly bracket x such that x exists in the real number system. What that means is every single domain value is going to be accounted for. Okay, now let's go ahead and look at the range. The range value is very, very similar. I'm still saying that all of my function has a corresponding y value, and I'm kind of indicating that right here. And if I were to continue this graph on, it would also continue to have a y value. And therefore, whether I'm going in the positive or negative direction, my range will be y such that y exists in the real number system. A little tip, anytime you have a linear equation or a line, it will always have a domain of x exists in the real numbers and a range of y exists in the real numbers. Okay, let's do a couple more here. All right, let's take a look at this next one. All right, this next one is a little bit different because I have an open circle and I have a closed circle. So let's just focus on the domain. My domain looks like it is from -5 up until 0. So let's go ahead and indicate that in set notation. X such that my lowest domain value is -5. But notice how it is not included, indicated by the little open circle. I'm going to use the less than symbol because equal to means it's also equal to -5, which we can clearly see that it is not. Followed by an X. Now, my highest value is going to be positive, or not positive, but 0. So I'm going to say that it also includes, it's less than or equal to 0. What this is saying that is all the domain values are in between these two numbers. If I were to write that in interval notation, it would look like this. I would use a parenthesis because my -5 is not included. And then I would end it with a 0 and I would end it with a bracket because it is included in my domain. All right, let's go ahead and grab my range values. All right, let's look at my range in green. All right, my range is going to be, it looks like my highest range value is going to be at 5, but it is not going to be included. And then my lowest range value is going to be -4, but it is going to be included. So if I represent this, I will say y such that my lowest is -4. It is included, so I'm going to use less than or equal to y. And my highest range value is going to be 5, but it is not going to be included. So I'm going to say less than 5. Okay, and my interval notation, it looks like it's going to be a bracket, -4, because -4 is included, comma, up to my highest, which is 5. And I'm not going to include it, so it's going to be a parenthesis. All right, let's keep looking at some more of these. All right, the next one, my domain value. Looks like my lowest domain is going to be -5, and my highest is going to be 4. Looks like both points are included, so let's go ahead and say x such that -5 is less than or equal to x, which is less than or equal to 4. My interval notation will be bracket, -5, comma, 4, bracket, since both numbers are included. And if I jump over to my range real quick, I can see that my highest range value is going to be 4, and then my lowest range value is going to be 3. So I'm going to say y such that -3 is less than or equal to y, which is less than or equal to 4. My interval notation will be bracket, -3, comma, 4, ending with a bracket. Okay, let's keep going here. All right, some more examples. If we remember this graph from the last section, this is an absolute value graph. So let's take a look at our domain and range. All right, let's look at my domain first. You can see that my domain, it looks like I have arrows extending in both directions forever and ever. If you remember, if I have, a corresponding domain value here and here and here, it's actually going to go on forever. So my domain values will always continue on because of these arrows. So I'm going to say x such that x exists in the real number system, all numbers. My interval notation, remember, infinity, negative infinity, is not a finite number, so I'm going to use my parentheses, negative infinity, comma, infinity, parentheses. Okay, well, this is kind of a cool one because my range is going to be different on this one. It's not going to be all real numbers. Let's actually see what my range is going to look like. All right, my range. It looks like my lowest range value on my graph is at 0. But it also looks like I have a range value on all of these little spots. So you can see either on either side, it doesn't matter. They all have a corresponding y value. And I could also continue this graph on, and it will continue to have corresponding y values. So what that means is my range is going to look a little bit different. I'm going to say y such that y is going to be greater than or equal to 0. It's going to include all numbers that are bigger than 0. A little bit different than before. And then it looks like my interval notation is going to be my lowest value is going to be an included value, which is 0. But then it's going to go up all the way to infinity, which is not a finite number, so I'm going to use a parenthesis. All right, let's look at another one like that. All right, let's first look at my domain value. Let me grab my blue. And it looks like my domain value, you can see that my arrows are going to be continuing this function here. And you can see as the function kind of slopes down like this, it's getting larger. So it's going to continue to get larger and larger and larger over time, or further and further away from the y-axis. Same thing in the other direction. It's going to continue going on in that direction. So you can see that even though it's gradually moving, it's, your domain values are going to always exist. So in this case, this is going to be x such that x exists in the real number system, which my interval notation will be the same, negative infinity all the way up to infinity. Now, my range values, let's look here. It's a little bit trickier to see. Okay, my range values, you can see that this graph will always have a corresponding range value. And no matter where I go on this graph, it's always going to also have a range value. So this is also going to be in all real numbers, y such that y exists in the real number system. Same thing with my interval. It'll be from negative infinity to infinity. Okay, I think I have 2 more examples with graphs, and I'm going to show you something else. Okay, for this one, my domain, it looks like my lowest domain is going to be at -2, and my highest is going to be at 4. So I'm going to indicate that by saying x such that -2 is less than or equal to x, which is less than or equal to 4. And my interval notation will be including 2 all the way up to 4 inclusive. Whereas my range value, it looks like my highest range is going to be a 3, and my lowest range is going to be at 0. So I'm going to say y such that 0 is less than or equal to y, which is less than or equal to 3. And my interval notation will be 0, which is included, up to 3. Okay, and the last one, feel free to pause the video as well and try these on your own and then check your answers with me. All right, your lowest x value. So my lowest x value is going to be at -2. My highest x value is going to be at 3. You can see that the function exists everywhere in between those 2 lines. So I'm going to say x such that -2 is less than or equal to x, which is less than or equal to 3. And my interval notation will be -2 inclusive up to 3 inclusive. And then my range, a little bit trickier to see in my opinion. Let me go ahead and erase my domain line so you can see. My range value is going to go up to 2, and it's going to go down to 4. Everywhere in between there will have a corresponding y value. So I'm going to say y such that -4 is less than or equal to y, which is less than or equal to 2. And my interval notation is -4 up to 2 inclusive. All right, now that we've looked at coordinate planes and graphs, let's go ahead and look at just coordinates. Coordinates, so I have these xy coordinates. I have 4 of them, and I'm just going to go ahead and quickly plot them. So I have 2, -3. I have -4 and 6. I have 0 and 5, and I have -2 and -2. So this right here, I've just graphed my my points. You'll notice that my points do not have lines connecting them. And therefore, if I'm asked for the domain of a set of ordered pairs, again, I'm just going to show my domain. My domain values are 2, -4, 0, and -2. And you could also put those in numerical order. That's fine as well. But I wanted to show you that you're not going to be saying that it's, my lowest is going to be x such that -4 is less than or equal to x, which is less than or equal to 2, because I don't have lines connecting it, meaning this point right here does not have a corresponding domain value. So I just need to be careful with that. Same thing with my range. My range with a set of ordered pair is just going to be the range value that are given to me in my coordinates. So those are going to be my range values. And one more thing I wanted to show you today, function notation. We've already talked about this a little bit, but I just wanted to touch on it. So sometimes we're given a function in function notation, and we're asked to find the domain and range. For example, if I gave you this function, f of x equals x minus 3, and I would ask you, what's the domain and range? The best way to determine the domain and range is to graph it on your graphing calculator. So you can see that I graphed this example here, and you can see that it's a line. And therefore, my domain will be x such that x exists in the reals. And my range will be y such that y exists in the real number system. Okay, so 2 little examples here. Go ahead and using your graphing calculator, go to your y equals, make sure everything is cleared out of it, and I'd like you to pop in the function -2x minus 5 into your y sub 1. If you press graph, you'll notice that you get a line. Again, another linear equation. All linear equations have a domain value of x such that x exists in the real number system. And they also have a range of y such that y exists in the real number system. But let's try this next one. This one is a quadratic. Go ahead and pop this one right into your y sub 1. If you graph this, you'll notice that you're given a function that looks kind of like this. It's a parabola. We've talked about that as we've been graphing these. And you'll see that the lowest point it has is on 0. And you can see that it extends forever in the positive upward direction forever. Therefore, my domain value for this one is going to be x such that x exists in the real number system. But my range is going to be a little bit different because my lowest range value is at 0. So I'm going to say y such that y is everything that's greater than or equal to 0. So basically, I wanted to kind of show you that if you're given a function in function notation, like these 3 examples here, you can always put it in your graphing calculator to determine what the domain and range value is from looking at the graph. So feel free to go back and look at some of these different things we've been talking about, and I will see you in the next lesson.